awesome, and it was really, really a big surprise to see him win the F1 championship. So I'm really happy about that, because it wasn't an easy race, but it was an amazing, amazing end to an F1 championship, and it's one I didn't expect. So really looking forward to next season already. But we're here for Advent of Code, so let's check out day 12. Day 10 and 11 were pretty fast. I'm not sure what this is yet, I haven't read it. I always open the day to make the thumbnail. I try not to read anything yet, just to be like as unprepared as possible, because yeah, it's best when it's all natural and raw. So yeah, let's start reading today's challenge. Day 12, Passage Pathing. With your submarine, subterranean subsystems subsisting suboptimally, okay. The only way you're getting out of this cave anytime soon is by finding a path yourself. Not just a path, the only way to know if you've found the best path is to find them all. Is to find all of them, right. Fortunately, the sensors are still mostly working, and so you build a rough map of the remaining caves, your puzzle input. For example, start A, start B, A C, A B, B D, A end, B end. Okay, this is a list of how all the caves are connected. You start in the cave named Start. Then your destination is the cave named End. An entry like BD means that cave B is connected to cave D. That's it. That is, you can move between them. So, the above cave system looks roughly like this. Okay. Your goal is to find a number of distinct paths that start at start, end at end, and don't visit small caves more than once. There are two types of caves: big caves, written in uppercase like A, and small caves, written in lowercase like B. It would be a waste of time to visit any small cave more than once, but big caves are large enough that it might be worth visiting them multiple times. So all paths you find should visit small caves at most once, and can visit big caves any number of times. Given these rules, there are 10 paths through this example cave system. Each line in the above list corresponds to a single path. The caves visited by that path are listed in the order they are visited and separated by commas. Okay? Note that in this cave system, cave D is never visited with any paths. So to do so, cave B would need to be visited twice, right? Okay? Yeah, okay, but you go out and then back in. This is not allowed. Here is a slightly larger example. The 19 paths through it are as followed. Okay. Finally, this is an even larger one. It has 226 paths throughout it. Okay. How many paths through this cave system are there that visit small caves at most once? Okay, so this is a recursion issue. Okay. And the connection can happen both ways, so. Okay, let's just get on with it, I guess. Let's make a copy for the day. Why doesn't my F2 key work here? It's still running. Let's stop that. Day 12. Change this, 12, 12, and the input for 12. This is fine. Let's remove all the code that we wrote for part 1 and part 2. For part 2 we can completely delete, because we'll write that later based on what we do in part 1. Okay, so we need to have a dictionary, string hash set string pass, new blah, okay. Because we will need to know where we can go from a single point. So to do this, we also add the inverse. So let's see. I can actually do it like this. For A is input dot, let's just say lines first, right? And then we can do lines, let me see. Select, split by a separator like this. Okay. Pum, pum, pum. Let me see. So we have them split it, and then we can do as a value tuple. So we have two strings here. So we can actually call this to list. And we can call this a list of string A, string B, like this, right? Okay. So this one can start out as lines to dictionary A, new hash set string, and we put in x.b, right? And now we can do the inverse of that as well. We do for each var path in lines if paths contains key. No, actually we can if not pass a try get value. And we do the inverse here, so path.b out var existing. We do here existing is new block. Existing is new like this. And we add in path.a. No, we actually don't do that because we do that the line below. We can do existing.add path.a. And here we do path.add path.b, comma existing, right? So this will map them both ways, so that should be fine. So now we have a lookup between a string and all the paths that go out from there. So that is good. And now we need to record traversals, right? So let's say we have we need to find the end path. So let's just say const string start point is start, const string endpoint is end. And now we need to write some branching code that will just walk the path. And we need to keep track of the visited paths and also how many times. And since it's just a simple rule for now, that you can have the lower letters, you can have them once, and the bigger letters, you can have them twice. So you can actually still use a hash set, but just use two of them. So that should be okay. So just thinking out how the function would look, right? So you can have void traverse or find exit string exit. we have this path info here. Hash set string visited, and we do a hash set string visited big. So the reasoning is the first time we add them to big. If they're already in big, we check if they're in visited, and if they're already in visited, then it's not allowed, right? And otherwise we just add them to visited and allow it as well. And we can also have like a the current path. We don't need to save it actually, I think, but yeah, why not? List string current path. And we have, yeah, okay. This could be a stack, right? Just pop it and we look at the last one to see where we go from here. Do I do it like that? Let's see. So what we could do here is var options is pass. Let's see. Pass the try get value current path.peak out var options. Right? And we do if, otherwise we have nothing to do here, right? So now we say for each string next path in options, I can just call it options actually, option. And now we test if this is a valid option. If let's see. So now we need to check if this is uppercase or not. I'm just wondering if this will bite me in the ass later, but for now let's just make something easy for it. Let's say if option dot to lower is option. Actually, we can do it to upper. Who cares, right? Okay, so here we can tell if we need to check it once or twice, and actually we can check if let's see, not visited contains option. Actually, we can say if it contains, we can continue, right? Because we said if it's a big one, we add it to visited big first, and if it already exists here, we have seen it twice, so it's no longer a valid option. So, okay, then we check if it's to upper, we do if visited big contains option, add to visited, else add to visited big. Okay. Actually, we can do it like this. If it's to option bigger and not here, we add it to visited, and else we add it to the other list, right? We inverse these, So if it's an uppercase room, so a big one, and it hasn't been visited before, we add it to the big visited one, and otherwise we add it here. Okay, so that's that part. We also need to make sure that we create clones of all the data for our next iteration. Let's see. And the result probably needs to be a list of paths as well. So yeah, bum, 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 bum. You can probably check here if option is endpoint done, else do more. Okay. So that is that. We need to let's also just keep track of it, right? So we have a list of stack of strings, valid paths, there's new block, and this will also be the return of this function. Here we do return valid paths, and here we do valid paths dot add current path. And actually this needs to be the cloned path, right? So if we make it to here, we visit the option. Okay, so here we need to make clones of everything. So here we do var new current path is current path dot. Is there a clone to array? Let's do new stack string. Does it have an initializer? We can just put this in here. New current path dot push option, and we do var new visited is new hash set string, and we put in the current collection of visited, and we do the same for the big one. Visited. Okay. So that are all those things cloned. Hey, welcome back. How did you fare today? Did you manage to finish yesterday's one? Let's see. Add to visit. Okay, then we need to do that here. New visited big dot push. No, just add actually option, and else we add it to the new visited dot add option. It's nice that you keep me company when I stream. I'm grateful for that. So thanks for stopping by. Let's see, if option is endpoint, and else we actually move on. And this will be new current path. And actually we can do it like this, because we don't track the other ones, so we can do it here. So we have that, do more, and now we can do a valid path, so add range, find exit, and then we do paths, exit, new current path, new visited big. All right. Let's see. I hate path walking. I took way too long today. So yesterday was very easy. Yeah, Yesterday was extremely easy and the day before that as well. So I think I just about finished this one. So yeah. Let's see if this works, and I'll try the test case first, I think. So var path valid paths is find paths, paths, exit point, endpoint, right? New stack, and we add in start. Doesn't it like that? Let's see. I can do it like this. Right. Visited is also a new, and I can do a new hash set of string, and I can also put in this one. And visited big can just be an empty one. Part 1, pass. Let's see, valid, pass, that count. Okay, let me just first put in this test input here for now. Right, and let's see. I need to start the different day. My bad. Program day 12. Not 21, day 12. Infinite loop. Item with the same key has already been added. Ah, sure. Yeah, okay. Let me just new. Let's just do it like this. And I do this to give it an extra scope, and I just swap them out. So now I can use existing within the same nesting twice. Right. So that is a trick if you want to use the same. Hey, welcome, Sanko Software. Glad to see you again. Did you fix yesterday's code? So yeah, here I'm doing a extra nesting of just accolades, and you can use that to create a custom scope so that you can reuse the same variable name twice within a bigger scope. So yeah, I just use this to quickly change this code. And it says 8 paths, is that correct? 10 paths, okay. Given the rules of time. Okay, so my code is missing something, and let's see which one worked and which didn't. Let's see, valid paths. Quick watch. Wait, what? It started at end. This is interesting. Why did I start at end? Did I give in the wrong... no, wait. This is really curious. Let me see. Let me see what I fucked up here. So these are the paths that exist. For start, you can go to A and B. Yeah, okay. And end can also come from A and B. Okay, so that's fine. current path is start. Okay. So we have from A, it goes here. No. So visit the new current path is this. It pushes A. So that is fine. Let's see. Yes. So this one gets added to new big. New current path has A, B. So it comes in here with current path. Okay, you read it from the... okay. My bad. Okay, so that is just visualized, or the internal ordering is reversed there because it's a stack. Okay, that's fine. So let's just see what the paths are. So I need to read this from the end, but it's still weird that it has parts in the middle. That's really strange. So does that happen when copying a new one or something? I made it with your inspiration. Yeah, that's great, man. Glad you resolved it. Okay, so here I'm doing something wrong. And I wonder if it's this one. So let's just make this into a list. This will also be a new list. And I can just make this to list. I want to make sure that I'm not seeing something here. Let's see, this is a list of string. Let's initialize like that, okay. This will be last. I mean, this is not great, but it should work. And this will become a list of string. Okay. Right. Now I'm really curious to see what's in here because it should probably be the same still, right? Yeah, still 6, but at least I hope that the ordering is preserved and makes some sense. Okay, so the first one is start AC. Is there even an AC? Yeah, okay. Then A, B, and okay. That is fine. Actually, let me just write this out for each var path invalid paths. Console.writeLine, and we do string.join, comma, path. So let's debug this for now. Let's see, we put it here, set next statement, we run it. Okay. Let's see what I missed here. So this is what we have. And this is what the example had. So we have this one. And that one. And that one. And that one. And that one. Should probably just run a diff and be faster, but it's okay. And this one, okay. Okay, so the ones that we don't have is start A, B, A, C, A, and... Wait, what? I thought we could only visit them twice. Did I read wrong? Aha, okay, my bad. Um, multiple times. Okay, there is no limit. Okay, my bad, my bad. So we actually don't have to keep track or of our... That is annoying. Why did I miss that in the beginning? Right, so we don't even care about that anymore. So if we run it now, we get 10 parts. Woo! Okay. Jesus. Yeah, I think I can run the real input now. Let's turn off the this part. Okay. I actually made it more difficult than it had to be. Let's see. Part 1. 3,000 pass exactly. Okay, 1. Okay, let's see. That's the right answer. Okay. After reviewing the available path, you realize you might have time to visit a single small cave twice. Specifically, big caves can be visited any number of times, and a single small cave can be visited at most twice. The remaining small caves can be... wait, what? Okay. A single small cave can be visited at most twice. The remaining small caves can be visited at most once. However, the caves named Start and End can only be visited exactly once. Yeah. Once you leave the Start cave, you may not return to it. Okay. Now the 36 possible paths. Okay. So basically, I need to do what I did right away, except for the... okay. So now we change this to lower. No, to lower. And visited big dot count is 0. Right. And let me just copy this before I do all of this, right? So basically I already did the hard part. Find exit 2. Actually, let me just restore it as I had it. Right, find exit 2. And this one becomes, let me see. Oh, I still need to comment it out here. Yeah, that's correct. Right, then we do... The names don't make any sense, but visited W. Okay, but wait a minute. No, it's more difficult actually. Sorry for that, I tore off the mic. Because you have to determine which of the lowercase ones you're going to duplicate. So what you actually have to do... Damn it. This is tricky because basically what you have to do is make a variation for every small one where you make one of them the target, right? So actually you need to run a modified version that says can be visited twice. So, okay, let me just say, instead of this, we will have string lower can be visited twice, bool has visited twice, right? And now we need to make a variation for each lowercase that exists and start it with that. And then deduplicate the man. No, that's not correct. Well, it is correct, but let me think. Because it can happen like at any part in the string. So for the entire enumeration, you have to pick each lowercase once. So yeah, I know of a suboptimal way, but I think that's the way I'll do it for now. Just to get it done, you know. But that means that I'll have to do some trickery. Let's see. Let's see. If it's lower, and we actually don't care, we want to know if option equals this one and not has visited twice. So okay, this one goes out of the window. So this one becomes the one that you do first. So let's see. If option can be visited twice and has not visited twice. But that's actually the condition that you want to do inside here, right? Let's see. Let's see. Not has visited twice and let me see. If it's visited, that means game over, unless it has not been visited twice and it's equal to that. If it's not, we continue, right? Let's see. There's a mistake in this bool still. Let's see. If it visited, we continue. But only if it's not that, right? Like this. So if we met this condition, but it's not this. Because in this case, has visited twice, we have not visited twice, and this is the one that can be visited twice, then we don't want to continue. But I'm just thinking of what the best way is to do this, because in here, let's see, I'm revisiting day 4, which I skipped, wondering how you parse the input. I can show you quickly. So for me, I do split by new line, or by double new line. Then the first entry will be this one, and the other ones will be bingo boards. So then I skip the first one and then I parse them as a board. So basically, that's too big to share. Okay. If you need help, I can put it in a gist somewhere. Just let me know. Let's see. Let me turn down the heat a bit and take a sip of my cappuccino. Let's see. I'm just thinking of what the clearest way is to do this. The thing is, there's stuff that needs to happen before and after, so I'm just thinking if there's a clear way, but I'm just making things complicated right now. So let me see. New visited big doesn't exist anymore. If it's an endpoint, else we do this. New visited, we add it unless it's the one. Yeah. And we do has visited twice is true here. So this is fine. We have our check here, and we do it again here to make sure that it's done well. And here we do has visited twice. And we need to pass lower can be visited twice. All right. Okay. So this is our logic here. Okay. Now we just need to make sure that the start version starts with each of these and then does a distinct on all the entries which are the paths. And I should probably already do this actually. So let's see, valid paths, and we just make this a list of string in this case. Actually, we can make it a hash set of string. Let's not care. Hash set, because we don't want to add double paths in here, which will happen because of my way of doing this, but that's okay. That is a-okay. And we do this. Oh. New current path. So we add it here. And we do union with. Modifies the current object to contain elements that are present in itself, the specified collection, or both, which is fine. And then we return this. Okay. So now for part 2, we do the same. Let's see, part 2. Let's just yoink this over. Switch back to the test case as well, because hey, we want to make sure this works. Okay, and now we actually need to find the lowercase keys. So we can just keep track of it here. Do hash set string lowercase paths is new. Okay, and by the way to have done this in the past in part 1 to not have an issue right now would be to have a counter of like a rule set for each path to give its behavior. That would have probably saved some here. Let's see, I need to comment out this one actually. And now we do, we can do it here. If path.a is a path.a to lowercase at path.a. So we do, let's see, if that contains path A. We do the same for B. could probably just write a regex for that as well, but this is just quicker. Why write a regex for it? So now we actually do hash set string. My keyboard cable is in the way. Let's see. Hash set string valid path is new blah, not new what. New, like that. Okay, and now we do for each string lowered in blah. Actually, we can do lowered path and this. And now we can do valid path dot union with boom. No, come on. Right. And here we do actually lower path false. Right. And now in the end we need to make sure that it's only added if it not exists. So we say string path is this, if not valid path contains path, come on. And then we do this. Because of our way of looping, all the, they will have a lot of overlap, right? What's the issue here? I need to have an extra closing statement. Okay. Stack Overflow, nice. Oh, okay. No, I actually messed something up. Okay, that is interesting. So with the copy pasting, I messed up the part 1 code. Oh, wait. Let's see. Now, this is my second one. Yeah, I trigger a stack overflow here. Jesus. How come? Because this was to upper. So it's good to know that I probably need to rewrite. So part 2, slightly larger example. The first example has 36 paths, okay. And my code didn't work, so. Let's see. Oh, actually I need to, there's something I did wrong there. I just reminded myself. I should not modify that one. I just need to set it to true there. Does that change the output? No, it's still 10 paths. Okay, let me see how part 2 fares here. So var new path is this. So let's see. Start. Okay, start shouldn't be allowed to be revisited, and that's stupid of me. Let me see. That is here. If option let's keep adding cases to this. So do I get even less options now then? Let me see. Start A, B, end. Start A, and start B. Oh wait, I nuked the whole uppercase rule with this, right? Let's see. Yeah. I'm an idiot for doing that. Let's see. Because the uppercase still can be visited more than once. Let's see, else. If option is option to uppercase. We don't care about it being visited. So this should probably be the first case actually. No, the first one is lighter here, but it will happen less frequently. So yeah, let's see. So now it already has 10. Yeah, okay. Let's see how many paths. 36. Okay, it works. Great. Now let's see if we can keep it with the stack, or that it gives a stack overflow, which means that we have to write it as a recursion, as a loop. Basically, any recursive function can be written as a loop if you want. So let's see if we get a stack overflow error here. No, we don't. So let's see. Boom, and we got it completed. Okay, so yeah, this was also a fairly easy problem if I just handled it a bit better, right? So yeah, 50 minutes, not bad, but I think we could have solved this like 10 minutes or more quicker. But yeah, so that was day 12. Whew, glad I got it figured out. So let's see, I'm going to put my extensions in a gist for you so you can use it. Let's see, github.com, create gist, extensions.cs, let's just call it like that. I think it's something like this, right? So these are my extension functions that I wrote and use here. And let me just add the, you said day 4, right? Boom, 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 boom. The issue there is that I have like a whole setup for the boards. So not sure if I should share that or not, but yeah. Let's see. Let's see. Create another gist. And basically you can just do it like this and do say var rows is this. Right. Something like this. Or maybe I could just paste it here. Ah, this is too long. Okay. And this is the parsing one. I think you can write this yourself, but yeah, it uses those functions and it skips, it divides it in two. So I hope that helps you a bit to save some time on parsing the inputs. So yeah, that was it. Let's see, a lot of mine look similar to those. I've been writing new ones over the last couple of days for today arrays. Yeah, let's see. I use dictionary with a node class, yeah. Yeah, these are all just like helper functions. I wrote something to get the secure cookie from Chrome for your Advent of Code session that's saved in like a session.txt. Then this one, the solution base class, it basically just has something to download the day input. So I never have to actually go to the site and download it. I can just create a new day file, specify the base here, and then I will have the input, the raw input as a string available for me to process. And then I have just like, you always write the same like input.split, right? This is always, okay, we split on new lines and it might be Unix or it might be Windows. So we do both carriage return and new line, and then we remove empty entries. So I just have a two lines alias that just returns a string array. And then you always have like, okay, we need to parse a whole bunch of inputs because everything are ints. So I have a .as int32s that works on both input and char array. So if you have like the 10 by 10 grid with single digit numbers, you can just do .toChar array and then as int32s. There is a try that will give them try to parse and just ignore any errors. Let's see, mismatch count. I don't even remember what this is for. Ah, okay. So it checks how many are not in the other string, right? Cool. Ah, this is some one I wrote recently for the 7-segment display. I have a Blazor wrapper that also gets my data. Does a lot more. Used AOC 202 2020 last year to polish my Blazor knowledge. Yeah, Blazor is fine. For those that don't know, it's like Microsoft's WebAssembly offering with some extra sauce added to it. But basically, it's like WebAssembly for .NET developers, right? Yeah, so this is all just like useful helper functions that I use. So, okay, so I think that wraps up day 12. It's been a fun day. I've been getting better. Like in the past, I would spend so much time writing stuff like this, just as recursive functions and branching. But after you've done them a few times, it gets easier to write them. You just have to keep your head with it. And like, it was a bit sad that I got like the rule for the first one wrong, because I made it that you could visit the uppercase letters twice, but it was actually unlimited. So, and then we went to the one where only one of them could be uppercase, or one of the lowercase ones could be used twice. So that's a variation. And the only way that I can think of that was to have like a loop to treat each one of them as their own special case and then just ignore all the duplicate entries that it will find. Because I think there will be a way to do something like that inside of this, but I just couldn't figure out a way to do it. So for me, the most logic thing to do was to get all the lowercase ones and just put them in a loop and treat each one as a special snowflake for a whole pathfinding session. So yeah, that's it. I probably could have limited the amount of things that it could try there, but yeah, it was fun. So I want to thank everybody for stopping by again, keeping me company during the stream, and maybe see all of you tomorrow. So bye bye.